Alright, today we'll continue working on our Star Wars theme project. We will add a depth star back to the page. We'll also make the refresh interval variable, and we'll see how it affects the look of the page and the performance of the computer. Then we'll change the star motion formulas to make an impression that our spaceship turns vertically and horizontally. Let's start with making a refresh interval variable. It will help us to tune up the settings of the motion. So in here, first, let's change this to the value of our slider. Here, if you remember, this is our refresh interval slider here. And we set the refresh interval value to the value of our slider. Now, if we refresh our page, our refresh interval is sitting at about 100 milliseconds. But if we change it, the refresh interval doesn't change. But look, if we refresh the page, our refresh interval updates. And the reason for that is, in order to change the refresh interval, we actually have to clear the previous interval and then start a new one with a new interval value. So here, I'll set moving interval to 0. Then moving interval is equal to this. And now we're going to put all of our code into a function called reset interval. Like so. And so we will call this function whenever we want to reset the interval. Now, let's see. Actually, before we create a new interval, we need to clear the previous one by adding this line of code here. So this just clears a previous interval, and then we start a new interval. Now, if we refresh our page, nothing actually happens. We don't see any stars on the screen. But if we adjust our refresh interval slider, we don't see anything as well. And that's because we actually don't have any event handlers that react to the change of input of our refresh interval slider to actually refresh the interval. So now in here, to refresh interval slider, we'll add a new event handler. So on input, when the input changes, we call our reset interval function. Now, when we refresh, again, we don't see any stars right away, but if we move the slider, we will actually see the stars with the according refresh interval value. And the reason we don't see the stars right away is because when we first load our page, we never actually initially run the reset interval function to start off our logic for making the stars fly up the screen. Now, to fix this issue, we need to call our reset interval function below after we declare the function. Now, when we refresh the page, the stars will appear right away. And now, if we lower our reset interval, they will refresh faster. And if we increase it, they'll refresh slower. just like we intended. And now, when we set the refresh interval to a low value, um, the browser needs to put more effort in to actually draw each individual frame in a certain period of time. Whereas with high reset intervals, the browser doesn't need to put as much effort in to draw each frame. So here, I'll actually minimize this window, and then I'll open Task Manager so we can see how much the performance is actually affected. So here, I'll increase the amount of stars so that the differences in CPU usage are more dramatic. So when our refresh interval is low, you'll notice the CPU usage is pretty high. Right now it's hovering at about 80 something, but now if we increase our refresh interval to the max, you'll see a pretty dramatic drop in CPU usage. So right now it's only at like 20 something percent. And so also on maybe a bit older computers, if you set the refresh interval to a really low value, your CPU usage will max out and your frames won't be able to actually refresh as fast. And so you might be decreasing the refresh interval but see no visible changes. And so the key takeaway here is that if your program is not working the way you intended to, it might not necessarily be the fault of your program. It might just be the hardware. The hardware might be the issue. Now, I also would like to demonstrate to you another way that we can clean the paths of the stars. Currently, if we go in our code, we just repaint over the previous stars with a black circle. But what if we clear the stars using the clearRect function available in Canvas that we actually use in here to clear the entire screen from stars. So here, let's replace this code with this function call. So here we call our clearRect function to clear a rectangle from the top left corner of the star to the bottom right corner of the star. And now we'll refresh the page and see how it works. And now it kind of works. It erases the previous positions of the star, but it is very slow, despite the refresh interval being at the lowest possible value. And also here in the middle, the stars aren't actually erased properly, and so we have this huge black spot in here. And so our previous way of doing it was actually much better. Now, the reason I'm showing you this is because in programming, there are usually a lot of different ways to solve a certain problem. And so if you're solving a certain problem and it's not really working, or it's not working really well, you can just explore and find different solutions to the problem that might work more efficiently. Now, the next feature I wanted to add is making the Death Star move as well and appear when the checkbox is checked. So currently, our Death Star is commented out or deactivated. So now we actually need to remove these comments. Oh, oops. we need to remove these comments to activate this line of code again. And actually in here, we can just get rid of these properties because we're going to be calculating the position and the size of a star in JavaScript. And we are also going to set the display property to none to make our Death Star invisible at first. So it's going to be there, it's just going to be invisible. Now when we refresh, the Death Star is actually here, but we can't see it because its display property is set to none. Next, actually, we're going to add an ID to the star so that we can access it through the JavaScript code. And here in JavaScript, we're going to add 2 new variables and then another line of code. So in here, we create a new variable called Death Star, which just represents our Death Star image. And in here, we create a new object in JSON format. And for now, it's empty, but later on, it's going to store properties of the Death Star before we actually write them into the style of the Death Star. In here, we just set our Death Star checkbox. Where is it? This here, or this, to unchecked by default. Now, the next thing is in our interval, after the speed, after we declare the speed, we add an if else block. And so in here, if the Death Star checkbox is not checked, it will go into this else at first. In here, it sets the height property of the DS style object to the height of the canvas divided by 40, which just makes the Death Star small, but not too small. Kind of like a nice middle ground. Here, we initialize the DS style X and Y properties to the center of the screen. And these X and Y properties will just represent the coordinates of the center of the Death Star, just like the X and Y properties for the stars represent the center of the stars. And now in here, we set the display property of our Death Star to none, so we make it invisible. Now, here in our calculations, the center of the Death Star does not actually move. The Death Star just grows with the speed multiplied by 2. And the Death Star style height is here, accounts for the Death Star size, and the Death Star top and left properties account for the Death Star's position on the screen. So in here, initially, we set the DS style's height and width. We update the height and width properties of DS style. So for DS style, we multiply it by 1 plus the speed multiplied by 2. And we multiply it by speed multiplied by 2 because we want our Death Star to grow faster than the other stars because we assume that the Death Star is closer. And here we just add 1 because if we don't add 1, this will be less than 1 and the Death Star will actually shrink in size. Here for our width, we set it to the height multiplied by 1000 and divide by 679. And This is because if we go in our inspector and hover over the star, you'll notice that x and y coordinates, the width and height values of our star are 1000 pixels and 679 pixels. And so by doing this, we conserve the aspect ratio of the star. So our star does not stretch or squish in any direction. Now in here, we calculate the left and top properties of the actual depth star by taking our x and y values, which are the center of the depth star, and we subtract here the width of the depth star divided by 2, and in here the height of the depth star divided by 2, which this gives us the coordinates of the top left corner of the star. And now in here, in this line of code, we just set the height property and the style of the depth star to the height that we calculated for it in ds_style. And then here we set the display property to block, so that, which just means to actually show the depth star. Make it not invisible anymore. Now here we only set the height property of the depth star, even though we calculate the height and width, because in HTML we only need to change either the height or the width of the image, and the other side will be scaled accordingly by the browser to conserve the aspect ratio. And here we calculate width simply because we needed to calculate the left position of the depth star. Now also in here, the reason we have plus px at the end is because for these left, top, and height properties, they require a px suffix at the end to work properly in the browser. And now here actually this plus sign is not the same as this plus sign. This plus sign here is used to add two numbers together, just the way you would expect it to work in math. But here we add a string and a number. And so what happens here is this number is being converted into a string or into text, and then these two strings, so this and this, are concatenated together. So now let's see how this works. So I'll actually reduce the speed so you get a more gradual approach. And now let's check off the depth star. And now the depth star starts far away and it approaches us. And now we just go towards the star. Let's just speed this up. And here we'll just zoom in endlessly into the star. And we'll continue zooming in until this image here, its height property gets so big that the browser cannot be able to display it anymore. And then it just glitches and stops showing it. So here we zoom in, zoom in, zoom in. We continue zooming in. Look at the height variable. And here it just glitches and doesn't show anymore. But our height here is actually increasing still. Let's make it so that the depth star disappears once its height gets greater than 100,000 pixels. In order to do that, in our interval, here let's add another if. So if the height property of dStyle, so the height of the depth start is greater than 100,000, remember this is scientific notation. So this pretty much just means add 5 zeros to this number. And 1 with 5 zeros is 100,000. So once the height of the depth star is greater than 100,000, it just unchecks the depth star checkbox. And this makes the program go into this else where the height of the depth star is reset and the depth star is not visible anymore. Now, if we refresh our page, let's display the depth star. Pay attention to the height property in here. So the height property is increasing. It's increasing. Now it's at 50,000, 60,000, 90,000. And once it reaches 100,000, the depth star disappeared. And so you can see display none. Now, let's make the spaceship turning. And to do that, first of all, in our HTML code, we need to add 2 sliders. One for horizontal turning and one for vertical turning. And both of these range inputs go from negative 100 to 100. The reason they go into the negatives is because when it's in the negative values, they'll cause us to turn in one direction, and positive values will cause us to turn in another direction, in the opposite direction. So in here, the negative values will turn us left, and the positive values will turn us right for the horizontal turn input. Now, in our JavaScript code, we need to add 2 new DOM elements, or 2 new variables that represent our new inputs that we added. So this represents our horizontal turn range input, and this corresponds to our vertical turn range input. Now, if we run the program as is, we have these 2 new inputs, but they don't do anything just yet. And now we just need to update the formulas for calculating the star's new position to account for turning motion. And to do that, at the end of our previous formula, we're just going to add this, and then add this. And so in here, we just take our horizontal and vertical turn values, and then we scale them to be proportional to the width and the height of the canvas. And so in here, you may be wondering why we have a minus here and a plus here. And that is because with the minus here, when we move our horizontal slider right, so the values are positive, we subtract this positive value, which means the stars will actually move left, because left is our negative direction. And now in here, actually in here, if we turn left, then this value here is negative, and when we subtract a negative value, it actually becomes positive. It's like we're adding a positive value, and so our stars will actually move right when we turn left. And now same idea for this. Now, if we move our horizontal turn slider right, we will turn right. And if we move our horizontal turn slider left, we'll turn left. If we move our vertical turn slider up, we move up. And if we move our vertical turn slider down, we turn down. Now, everything looks working so far, but we currently have a logic that makes new stars randomly appear on the screen, or appear in a random point on the screen. This worked well before when the stars went off the screen equally in all directions, but now when we turn, let's turn like this, you'll notice that the stars move away in one or two directions. So in one direction like this, and then in two directions like this. And when we do that, we have these black spots. We have these black spots that appear in here. And now we need to take that into account when we're putting new stars in. So here's our previous if that we had. And now we're going to update this logic with a new if. So in here, if our horizontal turn value is less than 0, so if we're turning left and the star exited from the right side of the screen, then we draw the star in on the left side of the screen. If the star exited, if we're turning to the right and the star exited from the left side of the screen, then we redraw it on the right side of the screen. And if this is 0, if we're not turning anywhere, then we just use our previous logic for putting a star in a random point on the screen. Now, this just does pretty much the same thing, but for stars exiting the top side of the screen when turning down, and stars exiting the bottom side of the screen when turning up. And here we just keep our time property the same as it was before. And now, when we refresh the screen, when we do a turn, the stars now reappear at the top of the screen, or the side away from which they disappeared. And now this looks more realistic. However, if we try to enable Death Star right now, and we turn, the Death Star actually turns with us as if it's chasing us, which isn't very realistic. Next time, we'll actually make it so that the Death Star moves separately from us. Are there any questions so far? All right, then thanks for watching, and I'll see you next Sunday.